All right, so we are going to graph some exponential functions. And just a reminder, if we have an exponential function, we have a base number. And in this first example, our base is 2, and it's raised to a variable exponent. So our variable is in the exponent position. And I just made some quick graphs and quick tables just to kind of save time here. But on these first few, I want to do these by creating a table first. All right, so if I plug in -2 for my exponent, I'm going to have 2 to the negative second power, which is 1/4. And then I have 2 to the negative first power, which is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. And 2 to the second power is 4. All right, so if I plot these values at -2, I'm going to have a very small number at 1/4. -1 is 1/2. 0 is 1, over 1 up 2, and over 2 up 4. Be about right here. Okay, so coming in from the left, we have very small numbers, and we start to kind of turn a quarter here, and it's going to go up very fast. Okay, and that's a characteristic of an exponential function. It starts very slow, and then it kind of turns a corner and goes up fast. All right, so also noticing here, no matter what my exponent is, I can have -10, I'm still going to stay above the x-axis. So my x-axis is actually going to be a horizontal asymptote at at y equals 0. Okay, and that's a horizontal asymptote. All right, so on part B, I changed my base to 3. All right, so if I plug in -2, this is going to be 1/3 squared, which is 1/9. And then this would be -1 as my exponent, so 3 to the negative first power is not negative, it's 1/3. It's positive 1/3. 3 to the 0 power is 1, then 3, and then 9. So if I plot those points at -2, I'm going up very little. And at -1, I'm going up 1/3. Over 0 up 1. Over 1 up 3. And over 2 up 9. 3, 4, 5, 6, 7, 8, 9, be way up here. All right, so the graph, even with the different base, has the same shape. Okay, the bigger the base is, the faster it's going to go up. Okay, so the higher it will go with these same x values. Okay, and again, I do have a horizontal asymptote at y equals 0. All right, so now I'm going to look at bases where I have a fraction as a base. All right, I'm going to write this a little bit differently. I'm going to write this as 2 to the negative x power, because if it were 1, I would have 2 to the negative first power, and that would make it 1/2. All right, so the negative tells us I'm going to put my base in the denominator. So this is just another way of writing this. So if I put in -2 here for x, I'm going to have 2, and that's a positive, to the negative, and x is -2, so this would be to the positive 2 power. So that's going to equal 4. 2 to the negative first power, So the opposite of -1 is 1. So this is 2 to the first power, which is 2. 2 to the 0 power is 1. And then I'm going to have 2 to the -1 power is 1/2. And then 2 to the -2nd power would be 1/4. Okay, so if I were to plot these points, I'm going to go over to -2 up 4, over 1 up 2, over 0 up 1, over 1 up 1/2, and then 1/4. All right, so if you can see what happens here, here I'm going to start up very high, and I'm going to go down and approach the y-axis. So again, I'm going to have a horizontal asymptote at y equals 0. But even more importantly, what happened here is because of that negative, I had a reflection over the y-axis. Over y-axis. Sorry, that's a little sloppy there. All right, so if I have a reflection, or if I have the negative in the exponent with x, I'm going to reflect this over the y-axis. Okay, if I have the negative outside, for example, if I have -2 to the x power, this is going to tell me to reflect over the y-axis or to turn it down. Okay, this tells us to flip it over. So there's a difference of where I have my negative here in terms of which direction I flip. So this next one is a graph of 1/3 to the x power. So again, this is 3 to the -x. Okay. And if I put my -2 here, I have 3 to the opposite of -2, so that's 3 squared, which is 9. 3 to the first power is 3, then 1, 1/3, and then 3 to the -2 is 1/9. All right, so again, over 2, 2, 3, 4, up 9, way up here, over to -1, up 3, 0, 1, 1, 1/3, 2, 1/9. So it's going to look like this. Okay, and just comparing these two with the same base, I basically just flip them over the y-axis. All right, so now we're going to do some transformations just based on what we see here. And these are transformations like we've done in the past. So because I have 2 to the -x power, I'm going to flip over the y-axis. And this part here tells me I'm going to shift, and that would be down 3. All right, so I'm going to just very lightly draw in what the parent function of 2 to the x power looks like. Okay, remember we have over 0 up 1, and it's going down. So this is what 2 to the x power looks like. So I know that if I put in the -x, it's going to look something like this, and then I need to shift this down 3 units. So my horizontal asymptote isn't going to be the x-axis anymore. It's going to go down 3 units, and here's my new horizontal asymptote, and that's going to happen at y is -3. So this graph is going to actually look like this right here shifted down 3 units. So I can bring this point down 1, 2, 3 units. And everything else is just going to shift down, right? Now this one tells me I have a negative here, and this is going to flip down because it's in front of the 2 instead of in the exponent. And this part tells me here that I'm going to shift up 1. All right, so again, if I look at just the parent function here, here's 2 to the x power, and I'm going to turn it down and raise it up 1. So this point is going to come up here, and I have a new horizontal asymptote, which is right here at y equals 1, and it's going to turn down. So instead of going up like that, it's going to go, where am I at here? It's going to go down, and I am looking at this way. I'm thinking I didn't put this in the right position. Oh yes, I did. And it's going to go down here. All right. On the next page, we're going to learn a new number, and this is called the number e. And this is a irrational number that a mathematician named Euler, or I should say Euler, created or identified. His name is spelled E-U-L-E-R, and this is Euler's number. It's pronounced Euler, okay, and that is the number e. And there is a definition here that basically says that when you increase this number here to a very large number, and then you have a large exponent here, you're going to get a constant of 2.7182818. So there's all these digits here, and this is very similar to pi. You know, 3.1415926. It keeps going on and on and on. There's no pattern. Square root of 2 is another example, irrational number. Those are numbers that we're pretty familiar with, and e just kind of fits into that classification. So generally we think of e being approximately 2.718, and if we kind of leave it there like pi 3.14, this is an approximate value of e. All right, so if I think of e as my base now, remember e is just 2.718. If this is my base, I'm going to graph this, but let's think of some things that for variables that we would know. I would know that e to the first power, right here, is 2.718, and e to the 0 power is going to be 1, because any value is 1. And then if I did the reciprocal of 1 over 2.718, I get this value, 0.368. So if we just look at these three values right here, and I plot the ordered pairs, if I have -1 is x, I'm going to go up to about 0.368. over 0 up 1, and over 1 up 2.7-ish. So it's going to follow this general pattern here, just like the examples that we saw where our base was 2 or 3. It's going to have the very same shape. So in this case, what's going to happen is I'm going to shift down. Okay, I'm going to have a flip down. And that would be over the x-axis. And this tells me I'm going to shift 3 to the right. All right, so if I look at the parent function, the graph of the parent function, this point right here is going to be shifted 3 to the right. So instead of 0, 1, I'm going to go 3 to the right. Sorry, 1, 2, 3. So here's that 3. And it is going to shift down. And that's going to be reflected over, there we go, reflected over the x-axis because of the negative sign here. And this is what I'm going to see here. Okay, it's flipping down, and my horizontal asymptote is still the x-axis. Okay, this time I just have, next time I just have a shift of 2 units to the left. Okay, so if I have these points graphed here, this is my parent function. I'm just going to shift all of this 2 units to the left. So here's my intercept here, and it's still going to come up and go like that. Okay, so this would be the graph of e to the x plus 2. Okay, next one, I'm shifting up 2. All right, so my parent function looks like this. So now I'm going to move it up 2 units. So here's where it's going to cross the y-axis. I'm going to now have a horizontal asymptote, not at the x-axis, but at y equals 2. And that's what my graph will look like if I shift it up 2 units. All right, so that is what we have with graphing exponential equations.